Welcome to PanGlobal's Correction Series, which features typical calculation problems and their suggested solutions from our subject matter experts. In this video, we'll work step by step through a problem that our technical staff have devised to help you apply knowledge and concepts gained from your PanGlobal learning materials. This week, we are looking at an example of the collision of two suspended objects. Two bodies with a mass 5 kilograms and 3 kilograms respectively hang side by side on separate strings that are 2 meters long. The two bodies are just in contact. The heavier body is drawn aside, keeping the string tight until its center of gravity is raised through a vertical distance of 600 millimeters. It is then released, and the two masses adhere on impact. Calculate the following: the velocity of the 5 kilogram mass just before impact, the conversion of energy immediately after impact, the loss of kinetic energy on impact, the vertical height through which the center of gravity of the combined system will rise. Pause the video now to work through the problem on your own, or keep watching for the step-by-step solution. Calculating velocity. Using the formula for velocity from the PanGlobal Academic Supplement, we know that velocity is equal to the square root of 2 times the gravitational constant, g, times the height of the body, h. Substituting the gravitational constant of 9.81 meters per second squared and the height of the body, 0.6 meters, the equation can be solved to provide a final velocity of 3.44 meters per second. Calculating common velocity. Using the formula for common velocity from the PanGlobal Academic Supplement, let the outcome, v, be the common velocity after impact. m1 is the mass of the first body, 5 kilograms, and the velocity of this mass was calculated to be 3.44 meters per second in the previous step. m2 is the mass of the second body, 3 kilograms, and as this body is at rest, its velocity is 0 meters per second. The law of momentum conservation, which states that the total momentum of a system remains constant, the problem can be solved by recognizing that the momentum of the first body plus the momentum of the second body must equal the momentum of the two bodies that are now adhered together after the collision. By substituting our known values and continuing to solve the equation, we find that 17.2 kilogram meters per second divided by 8 kilograms gives us a common velocity, v, of 2.15 meters per second. Calculating the loss in kinetic energy. To determine the loss in kinetic energy on impact, we must determine the kinetic energy of the system before and after impact. Due to the law of conservation of energy, we know that the kinetic energy of the body in motion immediately before impact is equal to its potential energy in the raised position. Potential energy is calculated by multiplying the body's mass times the gravitational constant times its height from rest in meters. By substituting our known variables, we find that the potential energy of the raised body is 29.43 joules. Thus, its kinetic energy immediately before impact is also 29.43 joules. Kinetic energy after impact may be calculated by multiplying half the mass of the system by its common velocity squared. Now, by substituting our known variables, we can calculate that the kinetic energy of the system immediately following impact is 18.5 joules. By subtracting the kinetic energy after impact, 18.5 joules, from the kinetic energy before impact, 29.43 joules, we find that the loss of kinetic energy in the system upon impact is 10.93 joules. Calculating the vertical height rise. If we let h equal the vertical height through which the combined system passes, we can calculate that the potential energy of the system is equal to 78.48 joules times h. As the potential energy of the system must be equal to the kinetic energy of the system immediately after impact, we can state that the potential energy, 78.48 joules times h, is equal to the kinetic energy after impact, 18.5 joules. Dividing both sides of the equation by 78.48 isolates h and gives a height of 0.236 meters. The center of gravity of the combined system will rise by 236 millimeters.